There were supposed to be 0 objects like this passing through our solar system. Then in 2017, there was 1. Then in 2019, there was 2. Now, in July of 2025, a third one showed up, and it is already pulling the eyes of every space agency on Earth. It is moving so fast and looking so strange that scientists are calling this the most important visitor we have ever caught from beyond our sun. That is the kind of story we tell here, the real findings without the wild exaggeration, told slowly enough that you actually follow it. If that sounds like the channel you have been looking for, hit subscribe and stick around, because the next part is the one that makes this story stop being simple. Up until very recently, our solar system felt like a quiet neighborhood. The sun sits in the middle of it, the planets loop around it, comets drift through the cold outer regions, and most of them were born here, billions of years ago, along with the planets and everything else. Scientists always expected a few visitors from far away to swing through every once in a while. They had theories about them, they had computer models. They just did not have proof. The night sky looked like our own little backyard, owned and tidy. Then, in October of 2017, a telescope in Hawaii caught a strange, long-shaped rock tumbling past the inner solar system. It was the first object ever confirmed to come from outside our sun's family. Astronomers named it 1I, which means first interstellar. Most people know it by its nickname, Oumuamua, a Hawaiian word that loosely means scout or messenger from far away. It did not look like a normal comet. It did not behave like a normal comet either. It tumbled strangely, brightened in ways nobody could explain easily, and then it left our solar system forever, heading back out into the dark between the stars. 2 years later, in August of 2019, a different visitor showed up, and the story changed again. This new object looked, smelled, and acted like a normal comet. It was named 2I/Borisov, after the amateur astronomer who spotted it from a backyard telescope. For a brief moment, scientists around the world felt a kind of relief. The first one had been weird, sure, but this second one was behaving exactly like the comets we know. The mystery seemed to settle down. People began to think that interstellar visitors were probably just comets, like our own, only from somewhere else. And then, for almost 6 years, nothing else came. Astronomers wondered if 1I and 2I had just been lucky finds, or if interstellar objects were actually very rare in our part of the galaxy. New survey telescopes were built. Bigger cameras were installed. Astronomers waited. The wait ended on July 1st, 2025, when a telescope network called ATLAS, the Asteroid Terrestrial Impact Last Alert System, picked up a new dot of light moving fast across the sky from a station high in the Chilean desert. At first it looked small and ordinary. Within hours, it looked like nothing else we had seen. The new object was given a temporary label, A11PL3Z. That was just the raw code the Discovery software spit out. A few days later, the International Astronomical Union confirmed what many were already guessing in private chats. The new object was Interstellar, the third one ever found in human history. It was officially named 3I/Atlas. The I stands for interstellar, and the Atlas part comes from the survey that caught it. That is how the third visitor earned its name, and how the count of confirmed interstellar objects quietly went from 2 to 3. Now here's the part that caught everyone off guard in the first few weeks. The object was not creeping through the solar system the way comets usually do. It was moving fast, around 61 kilometers per second when it was first measured. That is roughly 136,000 miles per hour. To put that in everyday terms, it is fast enough to cross the entire United States from coast to coast in less than a minute. Most comets that belong to our solar system, the ones born here, move much slower than that. The speed of 3I/Atlas was the first big clue that this thing had been born somewhere else entirely and was just passing through our neighborhood on its way. Where exactly it came from is still being figured out, but its long, curving path suggested it had been drifting through the Milky Way galaxy for an enormously long time, possibly longer than our sun has been burning. The sun is about 4.5 billion years old. Some models suggest that 3I/Atlas might be older than that planet itself, older than our Earth, and older than the moon above us. It could have been wandering through interstellar space for billions of years before it ever came close to us. In plain words, this little ball of ice and dust may have started its journey before our planet, our oceans, or our first forests even existed. Once astronomers knew they had a third interstellar visitor on their hands, the race was on to study it before it left, because there is no second chance. Once interstellar objects swing past the sun and head back out, they are essentially gone forever, lost in the dark between stars. So telescopes all over the world, and a few in space, were pointed at 3I/Atlas almost immediately. They were trying to figure out what it was made of, how it was behaving, and whether it had any surprises hidden inside its cloudy shell. The first big surprise came from the way it looked in early telescope images. Astronomers saw that 3I/Atlas was already active, even when it was still far from the sun. A cloud of dust and gas was wrapping around it, the kind of fuzzy halo that experts call a coma. That fuzzy halo forms when sunlight warms the surface and ices turn straight into gas, kind of like how a scoop of ice cream disappears on a hot day, only in space. That alone made 3I/Atlas look more like an active comet than a dry, dead rock like Oumuamua. But the way it was outgassing was not normal. A lot of the gas coming off the surface was carbon dioxide, which is the same gas we breathe out, and a lot more of it than anyone was expecting. Here is the next reveal, and this is the detail that really stands out in this whole story. Scientists expected 3I/Atlas to be a water-rich comet. Most comets we have ever studied in our own solar system are full of frozen water. When they get close to the sun, that water ice warms up and turns into a big cloud of water vapor, which gets pushed out behind the comet and forms bright, beautiful tails. That is the picture we have in our heads when we think of a comet. When the James Webb Space Telescope, the most powerful space telescope humanity has ever built, looked at 3I/Atlas, it did not find that usual picture. Instead, the chemical fingerprint that came back from the comet was wildly tilted. The ratio of carbon dioxide gas to water vapor coming off 3I/Atlas was about 8:1. That is the highest carbon dioxide to water ratio ever measured in any comet, anywhere, including the ones that were born right here in our solar system. To put that in everyday terms, imagine you are expecting a pitcher of lemonade and someone hands you a pitcher that is mostly soda and only a tiny splash of lemonade. That is how strange this ratio is to comet scientists. A team writing in a major journal said the number sat about 6 standard deviations away from the typical comet value, which is a fancy statistical way of saying it was not just a little different. It was wildly, unbelievably different, the kind of number you almost never see in real science data without sitting up in your chair. So why does that matter to anyone who is not a comet scientist? Because the mix of gases around a comet tells the story of how and where that comet was made. A comet loaded with water ice probably formed in the cold outer parts of its home star system, far from the parent star, where water could freeze solid. A comet loaded with carbon dioxide might have formed closer in, or under different kinds of starlight, or in a different kind of cloud of gas and dust. The 3I/Atlas cocktail was telling astronomers, in plain chemical words, that it came from a place with a history we have not seen before, somewhere in the Milky Way with its own recipe for making small bodies. Then came another surprise, this time from a different telescope watching the same comet. A huge radio observatory called ALMA, which sits high up in the Atacama Desert in Chile and is made of more than 60 antennas working together as one giant eye, spent hours listening to 3I/Atlas in millimeter wave light, a kind of light humans cannot see but machines can measure very precisely. ALMA found something that flipped another piece of normal comet chemistry on its head. The comet was rich in methanol. Methanol is a simple alcohol, the same family of molecules as the alcohol in a glass of wine, though obviously you would never want to drink space methanol. The interesting part was the ratio, not just the amount. In nearly every comet we have ever studied, hydrogen cyanide is more common than methanol. That has been the rule for decades. In 3I/Atlas, methanol was more common than hydrogen cyanide, the rule flipped upside down. That is nearly unheard of, and it added another strange fingerprint into the mix. Some scientists also reported a slight reddening of the light reflecting off 3I/Atlas as it came closer to the sun. A slight reddening can come from organic material on the surface, the kind of carbon-based molecules that are interesting to astrobiologists who study the chemistry of life itself. It does not mean there was life on this object. It just means the surface chemistry of the comet was complicated, layered, and full of carbon-rich compounds. In simple words, the more we looked, the more fingerprints we collected, and almost every fingerprint was unusual. And here is where the story turned into a mystery that news websites around the world could not stop talking about. Did you know that high-powered radio telescopes were aimed at this comet, looking for any sign that someone, somewhere, might be sending a message back at us? If that kind of moment sends a little chill down your back, do me a quick favor, hit the like button right now, and tell me in the comments what you would say if the radio did pick something up. I genuinely read these comments, and they often become the seed of the next video. By August of 2025, the story had crossed over from regular astronomy into something stranger. Avi Loeb, a well-known astrophysicist from Harvard who had previously suggested that 1I/Oumuamua might have been an alien probe, started writing publicly that 3I/Atlas also deserved unusual attention. He pointed out the high carbon dioxide ratio, the unusual lack of a bright dust tail in some early images, and the strange brightness pattern as the comet moved in. He did not claim outright that it was an alien spaceship. He argued, more carefully, that the scientific method requires us to keep an open mind about rare events and not dismiss them too quickly just because they sound like science fiction. Most other scientists disagreed, at least in their public statements. They pointed out that the comet was behaving like an active comet, that it had a coma, that it was shedding gas and dust, and that unusual chemistry can come from unusual origins without needing anything exotic to explain it. They said the alien spaceship idea was low probability, fun to think about, but not the simplest explanation of the data we already had. The debate was polite in some places and heated in others, which is normal in science when the data is genuinely strange and the stakes feel personal. Here's the part of the story you probably heard about the most, the so-called signal moment that pulled every space agency into the conversation. In late 2025, as 3I/Atlas swung closer to the Sun, two separate teams tried to listen for any artificial radio waves coming from it. One was the SETI Institute, a research center in California that has spent decades searching for signals from other civilizations. They used an array of dishes called the Allen Telescope Array, or ATA, that is built specifically to listen for narrow radio signals. The other was Breakthrough Listen, a project funded by the Breakthrough Prize Foundation and run out of the University of California, Berkeley. They used the Green Bank Telescope in West Virginia, which is the largest fully steerable radio telescope on the planet, with a dish 100 meters across, wider than a football field laid flat. The SETI Institute team pointed their array at 3I/Atlas for more than 7 straight hours. They scanned frequencies from about 1 gigahertz up to 9 gigahertz. In plain words, gigahertz is a measure of how fast radio waves wiggle up and down, and different wiggling speeds can carry different kinds of messages, just like different stations on a radio dial in your car. They listened carefully across that wide range, hoping to hear a narrow, repeating signal that might hint at a technology rather than nature. Then on December 18, 2025, the Breakthrough Listen team pointed the Green Bank Telescope at 3I/Atlas as it made its closest approach to Earth, and they turned the same kind of wide radio listening power on it. They watched especially for narrow band signals, the kind that nature almost never produces but human technology produces easily, like the difference between the roar of a waterfall and the steady beep of a smoke detector. We have been making smoke detector-style signals for 100 years, so we know exactly what they look like in the data. So what did they actually hear? Here is where the story turns out to be more interesting, not less interesting. The teams did not detect any artificial radio signal coming from the comet. No narrowband beeps, no repeating patterns, no hint of a transmitter. The skies were quiet. The headline, in news article after news article, was that the search came up empty. That disappointed a lot of people who were hoping for a real message from a visitor that had been wandering the galaxy for billions of years. But hold on, that is not the whole story. And this is the part most people missed in the headlines. The teams did not just listen, they also confirmed a sharp burst of activity from 3I/Atlas as it rounded the Sun at perihelion on October 29th and 30th, 2025. Perihelion means the closest point to the Sun on its path. As the comet whipped around the Sun at about 1.4 times the distance between the Earth and the Sun, the heat grew strong enough to trigger a real fireworks show. That bright moment, that signal in the language of astronomers, was a surge of gas, dust, and carbon dioxide pouring off the surface. It was not a radio signal. It was a brightness signal. The comet lit up in a way that could be seen from many of the largest observatories on Earth and from a handful of spacecraft in space, including Hubble, the James Webb Space Telescope, and SphereX, a NASA mission that maps the sky in infrared light, which is the kind of light just beyond what human eyes can see, the kind you feel as heat on your skin. In other words, the so-called mystery signal was not a message from another civilization. It was a real, measurable change in the comet itself. It was the comet waking up as it came close to the Sun, shedding its outer layers into space. And the reason scientists were forced to investigate so quickly is because that bright moment was not supposed to look like that. The chemical ratios coming out of it did not match the normal playbook. The level of activity was higher than predicted. So when the comet lit up around the Sun, every team with a telescope, every camera that could turn, every radio dish that could swing, pointed their eyes at it. That is when the news of 3I/Atlas went global. and that is when the world heard about it for the first time in a serious way. Here is one more pattern worth pausing on. Every time a scientist made a prediction about 3I/Atlas, the actual answer came back a little stranger than expected. The expectation, the first educated guess, was that it would look and act like 2I/Borisov, a normal interstellar comet. The reality was an 8-to-1 carbon dioxide to water ratio, never seen before in any comet. The expectation was that its gas chemistry would look similar to comets born in our own solar system. The reality was a methanol-rich signature that flipped the usual pattern upside down. The expectation was that the comet would brighten slowly as it neared the sun. The reality was a fast brightening event around perihelion, the kind that had the whole community opening fresh notebooks. That gap between what was expected and what was actually measured is exactly why this story matters. Each time, the surprise was small enough to still be explained by normal comet science. Each time, the surprise was also big enough that nobody could ignore it. So the story keeps teaching us, even after the comet is gone. While all of this was happening, a small fleet of spacecraft around the solar system kept their cameras and sensors pointed at the visitor. Mars got its own flyby moment. On October 3, 2025, 3I/Atlas passed about 17 million miles from the red planet, which sounds far, but in solar system terms is a near brush. That was close enough for Mars-orbiting spacecraft, including the European Space Agency's Mars Express and the ExoMars Trace Gas Orbiter, to take a serious look. Those spacecraft were not designed to study an interstellar visitor, but they happened to be in the right neighborhood, and engineers quickly figured out how to turn their instruments toward the comet and pull readings. In simple words, we had unintentional flyby missions, simply because the timing was right and the spacecraft were already there. NASA's Europa Clipper mission, on its way to study one of Jupiter's icy moons, even turned part of its Star Tracker camera, basically a navigation camera meant to keep the spacecraft pointed the right way, toward the comet. The pictures were taken as side observations, not the main mission, but real data that scientists will study for years. Spherex, the infrared mapper, picked up details about the comet's carbon dioxide coma. Hubble took sharp pictures. James Webb took chemical fingerprints. Almost every major space telescope on Earth or in orbit had a piece of this story, and the data is still being pored over.
So why should you, sitting here in your everyday life, care about a ball of ice and dust that is already swinging away from us? Because every interstellar visitor that passes through is a sample. It is a piece of another star system, sometimes older than our own, sometimes made under conditions we cannot recreate in any lab on Earth. When 3I/Atlas came close, it gave us a few short weeks to study that sample before it was gone. In those weeks, we learned that not all star systems produce comets like ours. We learned that chemistry across the galaxy is more varied than we expected. We learned that older, stranger objects can come wandering in from directions we cannot always predict. And we learned that we are getting better at catching them.
Now bend that around to us for a second. We live on a small planet in a quiet part of one galaxy among hundreds of billions of galaxies. We have only ever studied our own neighborhood up close. We have only ever found 2 interstellar visitors before, 3I/Atlas. Now we have 3. If 3 have shown up in just 8 years of searching, the math starts to suggest that more are out there, more are coming, and more are waiting to be discovered as our telescopes get sharper and smarter. That is not just a fun fact for a trivia night. That is a hint that the galaxy is busier, stranger, and more interesting than we ever really assumed. And there is a personal layer too, which is easy to forget when we are talking about telescopes and gas ratios. Most people alive today will never see 3I/Atlas with their own eyes. Even with a good backyard telescope, it is faint and far. But the science from it will shape textbooks, will shape new missions, will shape the way a whole generation of astronomers thinks about what is out there. The next time someone in your life looks up at the night sky and asks, "Are we alone?" the answer will quietly include this comet, even if the answer is still, no message, no aliens, just strange chemistry and an old traveler who came to visit and then kept moving. What comes next feels almost as exciting as the visit itself. By the time you are hearing this, 3I/Atlas is already on its way back out of the solar system, racing toward the dark between the stars. Perihelion was October 29th and 30th, 2025. Closest approach to Earth was December 19th, 2025, when it passed by at a safe but scientifically close distance. After that moment, the comet began to fade, dim, and eventually become too faint for any telescope on Earth to pick up. It will not return for tens of thousands of years if it ever does. So everything we know about it, we know because of a short window that has already started to close and will keep closing for the rest of our lives. Which is part of why so many research teams worked such long hours in late 2025. They knew the window was closing. Every hour of telescope time meant another spectrum, another measurement, another chemical fingerprint locked safely into the public record. And the science does not stop here. The James Webb data alone will take years to fully analyze. The spectroscopy, which is the careful study of how light splits into colors and tells us what something is made of, will keep producing papers for a long time. Even after the comet itself is gone, the data will keep telling stories, the way an old diary keeps telling stories long after the writer has closed the book. Now here is something worth saying out loud, even if it sounds simple at first. We did not hear aliens. We did not find a spaceship. We did not get a phone call from another star system. What we did get was something almost as powerful in its own quiet way. We got clear, repeated, careful evidence that another part of the galaxy has its own chemistry, its own history, and its own kinds of objects that do not match our quiet neighborhood. That is the real signal of 3I/Atlas. The signal is not a beep in the radio dial. The signal is the fact that we were here, watching, listening, measuring, and learning about a visitor that nobody alive will ever see pass by again. And that is exactly why this kind of story is worth following. Astronomy is not just about what looks pretty in the night sky. It is about building a careful record of what is actually out there, one honest observation at a time, and then being honest about what we still do not know. 3I/Atlas will be studied for years, maybe decades, and the answers it gives back will slowly change the way we understand comets, other star systems, and the Milky Way itself. Before we wrap up, take a second and think about this one more time. In 2017, we had 0 confirmed interstellar visitors. By the end of 2025, we have 3. That is a fast change. And the change came from better telescopes, not from a magic trick in the sky somewhere. It came from us, from the teams that built the cameras, from the observers that stayed up all night, from the engineers who figured out how to point a Mars orbiter at a passing comet just because the timing worked out. We are getting better at finding these visitors, and the more we look, the more the galaxy surprises us with what is really out there. If stories like this one are worth your time, hit subscribe and turn on notifications so you do not miss the next strange visitor or the next surprise from deep space. Then drop a comment below with this. Do you think it is more likely that 3I/Atlas came from a peaceful, calm star system or from a chaotic, violent place full of exploding stars and crashing planets? Your guess is as good as the experts right now, and the comments on that question tend to be some of the best conversations we have on this channel. Then share this video with someone in your life who still thinks space is boring. They are about to change their mind, and you will be the reason why. Thanks for watching all the way to the end. Keep looking up because the next visitor might already be on its way toward us right now.